Good day everyone, welcome back to our YouTube channel, and for today's video we're gonna talk about linear inequality into variables. And at the end of this video, you are expected to differentiate linear inequalities into variables from linear equations into variables, graphs linear inequalities into variables, and solves problems involving linear inequalities into variables.
Here are some examples of inequalities. Number less than 2. Number less than or equal to -1. Number greater than 0. Number greater than or equal to -2. Now let's learn about difference of linear equation and linear inequality. Second, is it a solution? Identify each ordered pair to see if it is a solution to an inequality. Third, graphs of linear inequality into variables. Learn to graph and identify the solution sets of an inequality. And fourth, word problem. Methods to relate linear inequalities to real world. Now let's learn first the difference of linear equation and linear inequality. I have here a table for you to easily understand the difference of the two. For a linear equation is an equation involving one or two variables whose exponents are 1. In the case of one variable, one solution exists for the equation. And for a linear inequality is any statement involving one or two variables whose exponents are 1, where inequality rather than equality is the center of the focus. And for the symbol, linear equation, I have here an equal sign, and for linear inequality, I have here greater than, less than or equal to, and greater than or equal to. For the solutions, there is one specific value of y for every value of x. And for linear inequality, multiple solutions can exist for the same value of x or the same value of y. And for the graph, linear equation, solid line in every situation. While linear inequality, a dashed line if there are greater than or less than but not equal to, and solid line if there are greater than or equal and less than or equal.
Let's take an example. For a linear equation, we have y equals 2x minus 4. Linear inequality, y is greater than 2x minus 4. So observe the two given example. Here we use equal symbol, and then here we use the greater than symbol. So for the slope and then y-intercept, as you can see here, we have the same value for the slope, which is 2, and the y-intercept, which is -4. Now let's graph. So we have here -4 for the y-intercept, and for our slope, which is 2. So the rise is 2 and the run is 1. Next, in linear inequality graph, the same, we have here -4, and for the slope, which is 2, rise is 2, and then run is 1. So the graph here is a solid line, while in linear inequality, we have dashed line. And there is a shaded part. So don't worry, i-discuss natin kung bakit naging dash line itong linear inequality and bakit meron siyang shaded part. Alright?
Now let's proceed to a solution of the linear inequality. An ordered pair x and y is a solution of the linear inequality if the inequality is true when x and y are substituted into the inequality. How about checking solutions? To check if a point or an ordered pair is a solution, first, plug it in for x and y. Second, we need to simplify. But the question here is, does it make a true statement? Example number 1, is -3 and 4 a solution of y is greater than -1? So this is a given inequality, y is greater than negative 1. And then we need to substitute 4 to our given inequality. So 4 is greater than negative 1. So that is true. So therefore, negative 3 and 4 is a solution of y is greater than negative 1.
Second example, is negative 1 and 9 a solution of 2x plus y is less than negative 3? So we need to substitute negative 1 and 9 to our given inequality and then simplify. So 2 times negative 1 is negative 2. Bring down 9 and negative 3. So we have negative 2 plus 9 is less than negative 3. So negative 2 plus 9 is 7. 7 is less than negative 3. So that is false. So therefore, negative 1 and 9 is not a solution of 2x plus y less than negative 3.
Now let's tackle the graphs of linear inequality into variables. So always remember, class, that graphs will contain a boundary line and a shaded half plane. The boundary line of a linear inequality divides the coordinate plane into two half planes. Only one half plane contains the points that represents the solutions to the inequality. So I have here an illustration. So this is the boundary line and the two half planes. How to determine the type of line to draw? A dashed line means points on the line are not solutions. Use for less than and greater than. So this is dashed line. A solid line means points on the line are solutions. Use for less than or equal to and greater than or equal to. So this is the solid line. Now I have here a table for you to easily understand. So kapag ang symbol sa ating given inequality ay greater than or less than, gagamit tayo ng dotted line. So kapag nakakita ka naman ng symbol na greater than or equal to or less than or equal to sa ating given inequality, gagamit tayo ng solid line. Remember that, class.
Now observe the given table. So observe the symbols. So if the inequality is y is greater than mx plus b or y is greater than or equal to mx plus b, the shade is above the line. And if the inequality is y is less than mx plus b or y is less than or equal to mx plus b, the shade is below the line.
Example, graph y is greater than or equal to x minus 2. So first, we need to identify the slope and y-intercept to graph the line of the inequality. So the y-intercept here is negative 2 and the slope is 1. Now let's graph. So here is the negative 2 or our y-intercept and the slope is 1. So why do you think we use solid line and not a dotted line? Remember, gagamit tayo ng solid line kapag ang symbol ay greater than or equal to or less than or equal to. So ang symbol natin ay may equal to. Alright, so automatic solid line siya. And above the line, ang ating shade kapag ang symbol ay greater than or equal to. Remember that.
So now, the solutions are 0 and negative 2 here, 0 and negative 1, 0, 0, 1, 0, negative 2 and negative 2, negative 1 and 3, negative 4 and negative 4, negative 5 and 5. So, as you can see here, yung lahat ng solutions natin ay nasa shaded region or nandun mismo sa ating solid line.
Now, let's test. Again, the y-intercept is negative 2 and the slope is 1. Let's test 0 and
0. We need to plug in 0 for the value of x and y in the inequality. So y is greater than or equal to x minus 2, which is the given inequality. We need to plug in 0. So 0 is greater than or equal to 0 minus 2. Let's simplify. So 0 is greater than or equal to negative 2. So this is a true statement. Therefore, the shaded part will include the origin 0 and 0. The shaded part will include the origin 0 and the line is solid. So kung mapapansin nyo, meron tayong same y-intercept and slope. Pero nabago na yung ating inequality symbol, which is less than or equal to. Now let's test 0 and 0. We need to plug in 0 for the value of x and y in the inequality. So the given is y is less than or equal to x minus 2. So i-substitute natin yung 0. 0 is less than or equal to 0 minus 2. So 0 is less than or equal to negative 2. So this is a false statement. Therefore, the shaded part will not include the origin 0 and 0. The shaded part will not include the origin 0 and 0 and the line is solid. Since we use less than or equal to, the shaded part is below the line. So here are the solutions: 0 and negative 2, 0 and negative 3, negative 1, negative 4, negative 2, negative 5, 1 and negative 1, 1 and negative 3, 4 and negative 4, and 5 and 2. So, ang mga solutions natin ay nandun mismo sa shaded part natin or nandun sa ating solid line. Next example, graph y is greater than negative 1 half x plus 1. So the slope here is negative 1 half and the y-intercept is 1. Now let's test 0 and 0 or the origin. We need to substitute the ordered pair in our given inequality. So 0 is greater than negative 1 half times 0 plus 1. We need to simplify. 0 is greater than 0 plus 1. So 0 is greater than 1. So it is a false statement. Therefore, the shaded part will not include the origin 0 and 0. And the line is broken or dotted line. So the shaded part will not include the origin 0 and 0. So this is the y-intercept, which is 1, and our slope is negative 1 half. So the line is broken or dotted line. Alright. So here are the solutions: 0, 3, 1, 2, 2, and 4, 3, and 5, negative 1, 3, negative 2, 3, negative 4, and 5, negative 5, and 5. So always remember, class, that a dashed line means the points on the line are not solutions. Next, graph 3x plus 4y is greater than negative 4. So first, we need to rewrite the inequality in slope-intercept form. Y is greater than mx plus b. Note that in solving inequalities follows the same procedures as solving equations. So the slope here is negative 3/4 and the y-intercept is negative 1. Now let's solve. 3x plus 4y is greater than negative 4. We need to change into slope-intercept form. 4y is greater than negative 3x minus 4. Let's simplify. We need to divide both sides by 4. So y is greater than negative 3/4 x minus 1. Now let's test 0 and 0. We need to substitute the given origin or the ordered pair in our given inequality. So we have 3x plus 4y is greater than negative 4. So 3 times 0 is 0. 4 times 0 is 0. So 0 is greater than negative 4. So that is true statement. Now let's graph. We have here negative 1 for the y-intercept and then the slope, which is negative 3/4. So this is a true statement, therefore shaded part will include the origin 0 and 0. So the line is broken or dotted. So here are the solutions that will satisfy the given inequalities. Next, graph x minus y is less than 1. First, we need to rewrite the inequality in slope-intercept form. Note that solving inequalities follows the same procedures as solving equations, but there is one special case. Remember, sometimes you may have to reverse the direction of the inequality sign. And that only happens when you multiply or divide both sides of the inequality by a negative number. Example, graph x minus y is less than 1. So first, we need to rewrite the given inequality into slope-intercept form. So negative y is less than negative x plus 1. Since we have negative y here, to make it positive, we need to multiply both sides by negative 1. So we have y is greater than x minus 1. Since we multiply both sides by a negative number, we need to reverse the inequality sign. So the slope here is 1 and the y-intercept is negative 1. So let's test 0 and 0. And we need to use the original inequality. So x minus y is less than 1. So 0 minus 0 is less than 1. So 0 is less than 1. So that is a true statement. So this is the graph, and since this is a true statement, therefore the shaded part will include the origin 0 and 0, and the line is broken or dotted. And here are the solutions that will satisfy the given inequalities. Note the graph of linear inequalities. If the inequality looks like as follows, x is greater than or equal to negative 2 and y is greater than or equal to negative 1, remember the graph of x is a vertical line and the graph of y is a horizontal line. Now, this is the graph of x is greater than or equal to negative 2. So we have here negative 2 and a vertical line. The shaded part is going to the right of the line. Next is y is greater than or equal to negative 1. So for our graph, so we have here negative 1 and a horizontal line. And since ang symbol natin dito is greater than or equal to, so yung shaded part natin ay yung nasa taas na part. Alright? Now, let's proceed to a word problem. Problem number 1. Sam and Alex play in the same soccer team. Last Saturday, Alex scored 3 more goals than Sam. But together, they scored less than 9 goals. What is the possible number of goals Alex scored? For the assigned variables, the number of goals Alex scored is A and the number of goals Sam scored is S. We know that Alex scored is 3 more than Sam did, so A equals S plus 3. And we know that together they scored less than 9 goals, so it will be S plus A less than 9. For the solutions, S plus 9 less than 9, we need to substitute the value of A, which is S plus 3. So we have here S plus 3 less than 9. Next, we need to simplify. So we have 2S plus 3 less than 9. And then we need to subtract 3 from both sides. So we have 2S is less than 6. And then divide both sides by 2. So S is less than 3. For our answer, Sam scored less than 3 goals, which means that Sam could have scored 0, 1, or 2 goals. And Alex scored 3 more goals than Sam did. So Alex could have scored 3, 4, or 5 goals. Problem number 2. Latrell is purchasing chocolate truffles to use as party favors. To ensure there are enough for everyone, he needs to purchase at least 211 pieces. Dark chocolate truffles come in boxes of 23 pieces, and milk chocolate truffles come in boxes of 22 pieces. Identify the inequality in standard form that describes this situation. Use the given numbers and the following variables. X equals the number of boxes of dark chocolate truffles. Y equals the number of boxes of milk chocolate truffles. Assign variables. X equals the number of boxes of dark chocolate truffles. Y equals the number of boxes of milk chocolate truffles. For our given 211 pieces, minimum number he need to purchase 23 pieces dark chocolate truffles, 22 pieces milk chocolate truffles, and our answer is 23x plus 22y is greater than or equal to 211. So thank you so much, grade 8 student. Thank you for listening and have a good day, everyone.